Hello everybody, this is problem 123 again, and in today's video we are gonna solve this problem named end product from hackerrank. So it says consider two non-negative long integers a and b, where a is less than or equal to b, and we have to compute the bitwise AND of all these numbers a plus 1 until b. Okay, the bitwise AND. Okay, so we're going to be given n pairs of a and b's, and we have to compute that value, and that's it. Actually, we just have to complete the function and product, and that's it. Okay, so basically we just have to do the bitwise AND in something less than linear time, because the constraints are lower bound is 0 and upper bound is this one, 2 to the power of 32. So we gotta do this in something less than linear time, because we can't afford to do in linear time here. Okay, so this is actually a pretty basic problem for those of you who are already at a higher level, and of course if you are at a higher level you have already figured out the solution, but we're gonna see the solution anyway. Well, the solution for this problem is quite simple. We are going to declare a variable ans, which is gonna be the final product, the bitwise AND product. Okay, so we are gonna solve this problem by getting the exact value of each bit. Okay, so we're gonna solve this problem bit by bit. Well, first we have to notice two interesting properties about AND product. The first one is that if you have at least one zero, it doesn't matter the amount of ones you have, the number of ones you have. You are gonna have that bit set to 0 in your answer, your final answer. Okay, so the only way to keep a bit on is if all the bits, if that bit is gonna be on in all the numbers that we are gonna run through. Okay, so since we are talking about consecutive numbers here, we can easily ask if a bit is gonna be on in every number. We just have to consider the range in which the maximum size, the maximum number of numbers in which that bit can remain on. If you want more than 4 consecutive numbers to have the second bit on, that's gonna be impossible, because you are gonna have, let's say, 2, 3, 4, and 5. Okay, those are 4 consecutive numbers, and in 4 and 5 you have the second bit is not on at all, it's off. So the maximum range for the second bit to remain on is gonna be 2 numbers, 2 and 3. So basically we just have to ask if the difference between b and a, the upper bound and lower bound, is greater than the range of that bit, which is I. Well, we do nothing, we just do the left shift of the variable I and continue. That bit is going to remain 0. Okay, but if it is possible, if it is probable that that bit can remain on during the entire range, well, we just have to ask if it is on in the lower bound and if it is on in the upper bound. And if this condition is fulfilled, then we just turn on that bit, and that's it. Why? Well, because we know that we have a range that can maintain that bit on, and if that range is composed only of numbers that remain that bit on, well, the first one and the last one should have that bit on. Okay, then you just return ends and that's it. This is actually the code that gets accepted. Well, this was a fun and interesting exercise about bit operations, actually bit by bit operations. I hope you guys enjoyed this video, and let me know if you have any questions in the comment box. I hope you share this video with those who need it, and see you in another video. Bye bye.